Okay, so next we're going to go over today's lab. Um, today's lab is basically going to be just introducing you to Multisim. And because I have a Mac, I can't download and install the Windows Multisim, so we're going to use the online version of Multisim. It's very similar to the Windows version. I actually like it a little better. It's not as full featured, but we'll get to that. Um, so basically, Multisim is a type of SPICE program. It simulates circuits. It's very useful in electrical engineering. I've also seen people use it for all kinds of other uses like solving differential equations and some really neat stuff. Multisim is not really used very widely, um, but it's actually a really nice program with a much better interface than some of the older SPICE programs. Another program that you'll probably use while you're here at Auburn in electrical engineering is LT-SPICE. Um, I recommend you get familiar with that one too. If you wanted to use that at home, you're welcome to, or install it on your own computer. You can download it for free. You probably just Google LT-SPICE. But I think Multisim is probably a little easier to use, and so I would recommend that you use that. Um, I'll let you read through most of this on your own. So I'm just going to go through a couple of basic things. Let's see here. So you can see some of the unit prefixes here and what they mean. And so if you use these in Multisim, you can just do this to basically, instead of having to type in a bunch of zeros. This is what the Windows Multisim window looked like right here. I don't know, whoever made this lab manual rotated it like this, which is kind of dumb because it's hard to read. But you can look over it in the PDF that's on Canvas. All right, so getting parts, you're going to go to place and then component, and then you're going to select a component, and then you're going to place it. And the online version of Multisim is going to look a little different, but the components will have the same name. So one of the main components you'll use is DC power, which is just your DC power source, and it looks like a little battery schematic, which I'm sure you've seen before in Physics 2 and in the circuits lecture. All right. You place them on here. If you double click on them, it'll open up the components information and you can change things. So that's really important. So here are the main components you're going to use for this lab. And I'm going to zoom in on this a little bit so you can see. Obviously, you're going to have a resistor, capacitor, the DC voltage source. There's also a DC current source. And then these two are really hard to find. So when you look in Multisim, you're going to look for a voltage-controlled voltage source and a current-controlled current source. And this is what they look like. There are other ways of doing it in Multisim, but to get everything to work properly, I recommend that you use these two. If you use LT-SPICE, you'll probably use a parameterized component, but that's a little different, so you'll have to figure out how to do that on your own. All right, so to connect circuits together, you're basically just going to click on one node and then drag the wires, and I'll show you in a minute how to do that. Naming nodes and changing the wire colors is really important. Here you can see in this example, this is named V out and this is named V in. So any set of wires that are connected together forms a node. So if you click on the wires, you can edit the node. That's kind of useful. So there's different kind of analysis types that you're going to play with today. The main thing that I would tell you is when you do, for example, DC operating point analysis, don't send me a screenshot in your lab report of these values. They're just text. So make sure you copy these values out and put them in a summary table. And I'll go over summary tables and how I want them in your lab report in a little bit. So some of the simulation types, you get interactive. I don't really like using interactive. That's when you use little multimeters that you place in your circuit. Then you have DC operating point. This is the one I use a lot. We'll use transient analysis and AC sweep and some of these other ones in future labs. Today we're going to use DC operating point, interactive. We're going to use DC sweep and parameter sweep. So DC sweep basically means you select a source in your circuit and then you can sweep the values by a certain increment. So this is what your input is, and then of course what you're going to look at is your output. And your output, you can select the power of something, you can select the current of something, and you select it there. You can also add an expression. There's all kinds of cool expressions you can add. You can look at the derivative of something, all kinds of cool stuff. You can subtract two nodes from each other, and in future labs you'll do some of that as well. So that's DC sweep, and that's what a graph looks like. Now the big thing with generating these graphs is make sure they're on a white background, and before you generate it, make sure there are no tabs open. If there are tabs open here, Multisim has some strange bug in it and it'll mess up. So to get rid of these tabs, hit this little X button. That's the cut button. Hit it multiple times till you see no more tabs here. Once all the tabs are gone, then run your simulation. If you don't do that, your graph might look right to you, but there might be some nuanced things that are wrong. Sometimes what I've seen is it'll actually graph the wrong voltage here, and you'll see a graph and you'll think it might be right, but in actuality it's not. So make sure you're very careful about that. Parameter sweep is something that a lot of students have trouble with. I'll let you read through the instructions, but basically this is the screen for it. Make sure you select a resistor, the name of the resistor. I think in the lab exercise it's actually going to be RB, so you'll have to pay attention to which resistor you're sweeping, and then what parameter you're sweeping. And I've seen people sweep the wrong parameter here, so make sure it's set to resistance. What the resistor value is that you place in your circuit that you're sweeping is not really important. It's just important that you set these points to sweep. And then the last thing, the thing that people forget all the time, is the analysis to sweep option here. You're sweeping the DC operating point. If you don't, you'll get this weird multicolored rainbow graph that is incorrect. So pay attention to all of these things when you are doing the lab. And then again, as with the previous sweep, you are going to select something here. So if you wanted to look at the power across a certain resistance range, then you can select the power here, or the current, or the voltage between two nodes, or whatever. Now if you just select one voltage here, this is assuming that this node Vin or Vout is relative to ground. So if you wanted to find the voltage between two nodes like Vin and Vout, which would be the, or Vout and Vin, which would be the gain, for example, you could say add expression and then say Vout divided by Vn, or if you wanted the relative voltage between the 2 points, then you could say Vout minus Vn, or whatever you want to do. And you'll use those in future labs. But a lot of students, they forget that voltage is actually the potential difference. It's the difference between 2 points. And when you only see one node here, that means we're assuming that it is relative to ground. So, and that's something that I'll show you in the circuit, but a lot of people forget to put the grounds in their circuit too, so don't forget to put a ground in there. And there's a parameter sweep graph, and yeah. Now here's the alternative ways for doing analysis. I do not recommend that you use these little multimeters. They clutter up your screen and they're just kind of annoying. They are useful sometimes, because when you do DC operating point, you might assume that the voltage is going, or the current's going in an opposite direction than what it's actually going in. So I would say make sure that you know that. But sometimes it's nice to verify that by using one of these little multimeters. So you can verify that the current's going in a direction that you're thinking it's going in. And there's a gotcha on one of the problems in this lab where the DC operating point will give you negative power. It'll give you the power absorbed, but the problem asks for power supplied. So a lot of people get that one wrong. All right, and so you're going to have a bunch of circuits to simulate, and I'm going to build one of these in Multisim Online for you so you can see how it's done, and then I'll go over some gotchas. And I think I'm actually going to go through exercise 5, which doesn't seem to want to pop up now. There we go. So I'm probably going to build exercise 5 since it has dependent sources in it, and so that way you can see what it looks like. All right.